Assalamualaikum, my dear students. I hope all of you are fine and doing well. So, in our today's lesson, we are going to discuss about the topic which is electron affinity and its periodicity. So, the word electron affinity, it is basically related to the electrons, and the affinity means to attract something, to attract something. So electron affinity is basically the amount of energy that is released when an electron is added to the outermost shell of an isolated gaseous atom. So the simple means affinity is the attraction or the tendency of an atom to accept the electron to form an anion. Basically, when we have a simple atom, it has equal number of protons and equal number of electrons in it. So when we are going to add an electron, so electron number increases and the atom will be changes into the anion. Now we are going to add the electron. It's mean the energy will be released. When in a process the energy is going to be released, this process we called as the exothermic process. The word exo mean the exit or the removal and thermic mean energy or heat. So the process in which the energy and the heat is evolved or removed. This process is known as exothermic process and electron affinity is the amount of energy. For example, here we have an atom that is present in the gaseous state and here we have an electron and we are going to add that electron in the outermost shell of this gaseous atom. When the electron get adds, now this will be changes into the anion and in this process here the energy will be released. This released energy is known as the electron affinity or the affinity of the atom towards that electron. Next we have its periodicity along group and as well as in period. So when we move from top to bottom and left to right, there are some factors that affect the electron affinity. What are these factors? The first one factor we have it is the atomic size. Then we have the nuclear charge. We have the shielding effect. All these are the main factors which affect the electron affinity. So how do the atomic size affect that? Basically, when we move from top to bottom in the group, we just see that the electron affinity decreases. So what is the reason behind this? Atomic number of hydrogen is 1, lithium is 3, sodium is 11 and potassium is 19. So the atomic number increases. In turn, the atomic size also increases. And the electrons or the valence shells are going away from the nucleus. For example, this is for the hydrogen. Then we have for lithium, it is having two shells. After we have sodium, it has three shells. And then we have potassium, it has four shells. So as we moving from top to bottom, there is an increase in the atomic size. So the shells are going away from the nucleus. So when we just add the electron, so the nucleus will pull it with less force. So that's why the less energy will be released. In turn, the electron affinity decreases from top to bottom in the group. But on the other hand, when we move from left to right, as this is for lithium, after lithium we have beryllium, again has two shells. Then we have boron, it has two shells. We have carbon, we have nitrogen, and so on. We have these, for example, this is lithium, this is beryllium, boron, carbon, nitrogen, and oxygen. So there is decrease in atomic size. Why there is decrease in the atomic size? The reason is this, the nuclear charge increases. When the nuclear charge increases from left to right, in turn the positive charge on the nucleus increases, and when it increases, it pulls the electrons more tightly towards itself. So the size of an atom decreases. When the size of an atom decreases, the valence shell goes near to the nucleus. In turn, it will attract the added electrons more tightly towards itself and released more energy. So when we move from left to right, there is an increase in the affinity for electrons. And when affinity for electrons increases, it's mean the more energy will be released. So it is basically an exothermic process. After that, we have some examples for the electron affinity. The first one example in which we have the oxygen, it is present in the gaseous state and we are going to add an electron. So it released almost 140.9 kilojoules per mole of energy. So we will have the sign over there minus. Oxygen will be changes into the anion and the electron affinity for 1. Then this anion have more affinity to add the electron because the oxygen, its electronic configuration is 1s2, 2s2, 2p4. Its last shell is having total 6 electrons and it requires 2 more electrons to complete its octet. So that's why oxygen can have 2 electrons. So the energy supplied, it releases minus 770 kilojoule per mole of energy. So it will be changes into the anion as O2 minus in the gaseous state and the electron affinity 2. So this is the simple electron affinity, that how the energy is released when we add an electron. Likewise, we have another example, fluorine. It belongs to group 7a. It requires just one more electron to complete its octet. So by adding one electron as it is in the gaseous state, then atom will be changes into fluoride ion and the total electron affinity or amount of energy released will be minus 337 kilojoule per mole. So this is the electron affinity for the fluoride ions. I hope you guys understand about the topic, and if you have any queries, you may ask me about that in the comment section and I will get back to you guys soon. The next topic that we will discuss, it is the metallic and non-metallic character of the elements in the periodic table. For that time, you guys have a good day and Allah Hafiz.